Ingot casting is the primary stage of metal manufacturing. Before molten steel can be forged, rolled, or extruded, it must first be cast into an intermediate form capable of withstanding extreme mechanical deformation.
Ingots are an intermediate geometry, not a finished product. This primary stage serves strictly to convert raw molten metal into a solid, manageable form, explicitly designed for subsequent physical working.
This process represents a critical link in the metal manufacturing lifecycle. We do not cast final components directly. The ingot acts as the necessary physical bridge between fluid processing and solid-state mechanical deformation.
Tooling geometry is dictated by the need for safe extraction. The walls of the iron mold are deliberately tapered to ensure the mold can be lifted clear without mechanically locking around the solidified steel.
When molten metal contacts the relatively cool iron mold, heat transfer is aggressive. This produces a distinct solidification pattern. The exterior freezes rapidly into a solid shell, trapping an entirely liquid core inside.
The root cause of many casting defects is volumetric contraction. As metal transitions from liquid to solid, it contracts. If it cannot draw in sufficient additional molten metal to compensate for this shrinkage, it will physically tear itself apart from the inside.
Inadequate feeding during the final stages of solidification results in the piping defect. This uncompensated contraction creates an undesirable internal cavity or depression known as a pipe.
The pipe acts as a magnet for chemical and structural weakness. Impurities are pushed into the remaining liquid and concentrated around the pipe, while exposure to the atmosphere leads to oxidation that compromises the steel's integrity.
Defects do not disappear during downstream deformation. Mechanical rolling cannot weld the oxidized, impure surfaces of a pipe. Instead, the pipe becomes an elongated internal fracture, serving as a permanent source of weakness in the finished component.
Engineers utilize several strategies to mitigate contraction, including slow pouring to regulate cooling, rotatable molds to use gravity, or specialized hot tops to provide additional liquid metal reserves. The hot top defeats piping by acting as a thermal reservoir. By maintaining localized molten metal, it actively feeds the contracting ingot, effectively forcing the pipe defect to form outside the usable ingot body. Achieving premium quality often requires deliberate material rejection. Because the top region absorbs the impurities in piping, it must be cut off and discarded. Engineers intentionally create waste to ensure the integrity of the final product. In summary, the ingot casting defect control loop connects thermal physics and engineered geometry to manage inevitable contraction, ensuring that downstream products are free from the internal fractures caused by casting defects.